Linear inequalities are solved in a very similar manner that linear equations are, the primary difference being that the solution to an equation is a finite, or fixed, value, whereas the solution to an inequality is a range of values. The operator used in equations is the equals sign. The operators used in inequalities are greater than or equal to, less than, and less than or equal to. To illustrate the difference between equations and inequalities, consider the equation, x equals 4. The variable, x, carries a finite, or fixed value, which is 4. Now consider the inequality, x is greater than 4. What this means is that x can carry any real value larger than 4. If x is an integer, and x is greater than 4, then x can be any integer in the set 5, 6, 7, 8, 9, etc. Only integers have been listed in the set, as we defined x as an integer. However, if x were any real number, then the set would include any real number greater than 4. In this case, x could be any rational or irrational number. If x is greater than or equal to 4, the set would include 4, as the inequality sign is inclusive of 4. If x is less than 4 and x is an integer, then the set would include all integers less than 4. And if x is less than or equal to 4, then the set would include the integer 4 and all integers less than 4. Only integers have been listed in the set, as we defined x as an integer. However, if x were any real number, then the set would include any real number greater than 4. In this case, x could be any rational or irrational number. Because the solution to an inequality is a range of values, inequalities are also usually represented graphically on a number line. The equation, x equals 4, can be represented on a number line by placing a closed circle above 4 on the number line. Because we have a finite solution, we indicate this by placing a closed circle above the number 4 on the number line. The solution to x is greater than 4 is represented on a number line by first placing an open circle above 4 on the number line, and then pointing an arrow to the right, to indicate all real values larger than 4. Since the solution is greater than 4, the solution does not include 4, so we indicate this by placing an open circle above the number 4 on the number line. The solution to x is greater than or equal to 4 is represented on a number line by first placing a closed circle above 4 on the number line, and then pointing an arrow to the right, to indicate all real values greater than or equal to 4. Since the solution is greater than or equal to 4, the solution includes 4, so we indicate this by placing a closed circle above the number 4 on the number line. The solution to x is less than 4 is represented on a number line by first placing an open circle above 4 on the number line, and then pointing an arrow to the left, to indicate all real values less than 4. Since the solution is less than 4, the solution does not include 4, so we indicate this by placing an open circle above the number 4 on the number line. The solution to x is less than or equal to 4 is represented on a number line by first placing a closed circle above 4 on the number line, and then pointing an arrow to the left, to indicate all real values less than or equal to 4. Since the solution is less than or equal to 4, the solution includes 4, so we indicate this by placing a closed circle above the number 4 on the number line. To clarify the different notations, an open circle on a number line indicates values that are excluded from the solution. And a closed circle on a number line indicates values that are included in the solution to the inequality. In other words, the inequality signs, greater than, and less than, are represented on a number line as an open circle. And the inequality signs, greater than or equal to, and less than or equal to, are represented on a number line as a closed circle. Whenever the straight line underneath an inequality sign is indicated, this means that the inequality is inclusive, which is represented as a closed circle on the number line. The principles that apply when solving linear equations also apply when solving linear inequalities, with the exception that, whenever multiplying or dividing the terms by a minus sign, the inequality sign reverses direction. We can illustrate this by solving this inequality in 3 different ways. Firstly, we can move minus 4x over to the right to get 2 is less than 4x. At this point, it is important to note that the inequality sign does not change when all we are doing is moving terms across. We only reverse the inequality sign whenever multiplying or dividing by a minus sign, which will be illustrated in a bit. Back to the problem. To solve for x, as we do with linear equations, we can now divide both sides by the coefficient of the variable, which is 4. Thus, 2 over 4 is less than 4x over 4, which means that a half is less than x. Now, Since inequalities are generally written with the variable on the left, we rearrange this inequality as x is greater than a half. To clarify what we just did, notice that the mouth of the inequality sign is facing the variable. Therefore, when rearranging the inequality, such that the variable is on the left, we reverse the inequality sign. Notice that the mouth of the inequality sign is still facing the variable. The second way of solving this inequality is by moving the constant term, 2, across to the right, and then divide both sides by the coefficient of x, which is -4. However, when dividing by -4, you also need to reverse the inequality sign. Therefore, x is greater than a half. The third way of solving this inequality is by multiplying each term by -1. Recall that whenever multiplying or dividing terms by a minus sign, the sign of each term changes to the opposite sign. The same is true when it comes to inequalities, but whenever multiplying or dividing the terms of an inequality by a minus sign, we also, at the same time, reverse the inequality sign. So, multiplying or dividing each term of this inequality by -1 means that +2 becomes -2, and -4x becomes +4x. Of course, 0 times -1 is still 0. However, because we have multiplied each term by -1, we must, at the same time, reverse the inequality sign. Therefore, -2 plus 4x is greater than 0. We can now move -2 across to the right, and then divide both sides by 4, to give the solution, x is greater than a half. Solving linear inequalities is very similar to solving linear equations. The primary difference is that linear equations have finite solutions, whereas linear inequalities have a range of solutions. Thus, when solving linear inequalities, we will start by isolating the variable, by moving all constant terms to one side of the inequality. So, moving -11 across to the other side of the inequality, we get 6x is less than 2x plus 7 plus 11. We can also take 2x over to the left, which gives us 4x is less than 18. We can now divide both sides by the coefficient of 4x, which is 4, to give us x is less than 9/2. Inequalities are also represented on a number line. First, we list the value 9/2 on the number line. We then place an open circle above this value, to indicate that 9/2 is excluded from the solution. We exclude 9/2 as part of the solution because the inequality is exclusive. Since x is less than 9/2, we place an arrow pointing to the left of the open circle, to indicate all values of x that are less than 9/2. In order to isolate x, we will first need to remove the brackets by multiplying out. Thus, 7x minus 6 plus 4x is greater than 5x minus 15. Taking all x terms across to the left, and constants to the right, we get 6x is greater than -9. We can now divide both sides by 6, to give us, x is greater than -3/2. Again, we represent the solution on a number line. Because the inequality sign is exclusive, we place an open circle above -3/2, and an arrow to the right of this value, to indicate all solutions of x that are greater than -3/2. In this example, since we have fractions, we will first find a lowest common denominator. The lowest common denominator of 2, 3, and 12 is 12. Thus, we multiply 3x minus 1, and 2 by 6, 3 minus x, and 3 by 4, and 2 over 1 by 12. So, 6 times 3x minus 1 over 12, minus 4 times 3 minus x over 12, is less than x over 12, plus 12 times 2 over 12. Since all the denominators are now equal, and are non-zero, we can simply drop them. Thus, 6 times 3x minus 1 minus 4 times 3 minus x is less than x plus 24. Multiplying out we get 18x minus 6 minus 12 plus 4x is less than x plus 24. Taking all variable terms to the one side, and all constants to the other, we get 21x is less than 42, which means x is less than 2.